In this video, I'll explain the logic of quicksort algorithm. Okay, the quicksort is a recursive algorithm where we have to recursively sort the left and right parts of the list of elements. Okay, so I take for in this logic I have for this quicksort I take a function quicksort which is three variables. Okay, this is a prototype of quicksort. Okay, one is array, to pass array through the function quicksort, and another variable is setting the first element, and another variable is last element of the list. Okay, so now I am calling the function quicksort where n is the array of elements we are passing. Suppose if the array elements are 5, that 5 element will pass into the array. Next, the first element, here the value of the first element is 0, and the last element is number of elements in the list. Suppose if there are 6 elements, 6 minus 1. So here I was sending the value of last as size of the array, and 0 for value of the first is 0. I am initializing values first and last like this. Okay, now in this quicksort I am checking like this: if first is less than last. Now these are the same example, these are the list of elements. Okay, for the same example, these are list of elements. Okay, so here the size is 3, 1, 2, 6. That means n minus 1 count is 5. We will take count as 5. Okay, count 5, first 0, last value is n minus 1, count minus 1. That means 6 minus 1, 5. Okay, 5. Next, here if first is less than last, first is 0, 5, 0 is less than 5, the condition is true. Now pivot, assign pivot as first. Pivot means what? This one, 0 element. Okay, 0, pivot is equal to 0. Next, I equal to first plus 1, means first plus 1 means 0 plus 1. I am setting this as I, left element. I means here what? Left element. Next, last element, j equal to last. Last element means what here? Right element, 5. Okay, next, while I less than j, I means what here? 1. 1 is less than j. The condition is true. Okay, now again you compare. If while n of I means what? N of 1, that is 23 less than equal to pivot, and here the condition is true. N of I, this is less than pivot, and I is less than last. Last means what here? 5. That is I 1. 1 is less than 5. So the both conditions are true. Then you increment I with 1. Now it comes to this position. I is 2. Okay, now again check. N of I means what? 17. Less than n of pivot means 29. True. And I 2 is less than 5. Again condition is true. So increment I with 1. Now this is the I value. Okay, 3. N of 3 less than pivot. N of 3 means 34 is less than n of pivot. Pivot 29. So this condition is false. So it control comes to this statement now. It check. Again we are checking the right part of the subtree. Okay. Now n of j means 5. N of 5 greater than pivot, false. N of 5 means 27 is less than pivot. So the condition is false. Now it stops here and comes to this statement control. Okay, I less than j is if I less than j, I means what here now? 3, j means 5. The condition is true. Now here we are swapping that means n of I value with n of j value like this. Now the list is like this. Now again control goes here. Okay, again you check. Is while I less than j. I means what here now? 3 is less than j. 5. Okay, condition is true. Again, if while n of I less than n of pivot, what is n of I here? 3, 27. N of 3 is less than n of pivot. Condition is true and I is less than last. Here also true. 3 is less than 5. So I is incremented with 1. The position of I is here. Okay. Now again it will check. N of I, that means 65, n of pivot. The 65 is less than pivot. The condition is false. Now control comes here. Again check the right element. N of j means this one. J, right element, is greater than n of pivot. Yes. J is decremented with 1. So now the right is here. Now again compare. N of j means what here? This one. J. 65 is greater than 29. Yes. Again decrement. So the right comes here. Okay. That means j value. Okay. Now again it will compare. N of j is greater than pivot. 27 is greater than pivot. No. The condition is false. Again it stops here. Left is here and right is here. Again it compare here. If I less than j, what is I? 4, j 3. 4 is less than j. The condition is false. So it does not execute this statement. It comes here. Temp equal to n of pivot and it will make a swap with the pivot element and we'll get this list. Okay. Now again we will swap this subpart, left subpart and right subpart. This function is to call the left part of the subarray and this is to call right part of the subarray and continues the same process to sort the left and right part of the subarray. In this way the quicksort algorithm goes in this way. Okay.